All right, let's do this Lebesgue measure integration problem. So suppose f is a non-negative integrable function. For each n, define e sub n is the set of all x and r such that f of x is greater than or equal to n. We want to prove that the infinite sum of all these measures is less than or equal to the integral of f is finite. So notice that this part is automatic because we're given that f is integrable. So that means that the Lebesgue integral is finite. Okay, so now we're just worried about proving this part. When we look at this infinite sum of measures, we immediately think of the indicator function, right? Because recall that the indicator function, the integral of that is just equal to the measure of e sub n. And this is really intuitively seen. So like over our e sub n, our indicator function will equal 1. Everywhere else is equal to 0. So when we do integrate this, we get 1 times the measure of our e sub n. Okay, so now that we know that, why don't we set our indicator function to be the sum, the infinite sum, right? Because then we see that when we integrate that, maybe we can get something that looks like this. And also, so, okay, let's do that. Let f sub n equal the sum, maybe f sub k, n equals 1 to k of chi sub n x. And notice that our function will be monotonically increasing, so, or monotonically decreasing, because we're making our threshold higher and higher and higher. So there will be less values of f of x that satisfy x being an e sub n. So since they're non-negative and monotonic, we can apply Lebesgue's monotone convergence theorem, which tells us that we can pull the limit inside. So what does that tell us? It tells us that we can pull this limit inside. Okay. And now by the linearity of the integral for finite sums, this is just equal to limit as k goes to infinity of the finite sum of our chi sub n's. Now this part is a bit trickier, right? So this inner part is equal to the infinite sum of all our chi sub n's over our set e sub n's. And notice that this is just another way of writing the floor function of f. So why is that? Well, think about when we're summing all the values from 1 to infinity of chi of e sub n for a given x. We are essentially summing, so we have like an x here, and then we start with like 1. So let's say n equals 1 is here. So yes, x is bigger than that. N equals 2. Yes, x is bigger than that. N equals 3. Yes, x is bigger than that. But n equals 4, no. So from n equals 4 on, we'll just have zeros. But this just gives us 3, which is the floor of f of x. Oh, this is f of x. So this is equal to the floor of f of x. And notice that that's always less than or equal to f of x. So when we integrate both sides, we will get that this is less than or equal to the integral f dm. And so now we see that this part just easily will become, so remember that this is measure of e sub n, so this just immediately just becomes infinite sum of the measures. and we're done. And one thing to notice is that because our infinite sum is finite, by the nth term test, we know that as n goes to infinity, our measure of our e sub n's goes to 0. And that kind of makes sense because, again, we're increasing the threshold, so the measure of that should get smaller and smaller and smaller and smaller, and eventually go to 0. And we're done.